Hello again. So in this video, we're looking at set notation. We're doing this so in a later video, we can look at calculating probabilities using Venn diagrams. First question is, what is set notation? Well, set notation is a way to describe collections of objects, and they are called sets. And a set is just a group of things that are related in some way. So these things can be numbers, they can be letters, or they can be any other items. Here is an example of a set that includes fruit. We designated the set with a capital letter F, and that designates this group of items. And we can see in this group of items, we've got an apple, a banana, an orange, and a grape. So set F, this is set F. This is all of the elements in set F. So set F contains four elements: an apple, a banana, an orange, and a grape. Each item in the set is a type of fruit. So it's new language, but actually, if you look at it, it's quite logical. So in this set, we have four items of fruit. The set is shown by these curly braces. So we can say that a banana, or we can say that banana is an element of set F by writing this. Banana is an element. So this, almost like a C with a line through it, designates the term element. So banana is an element of set F. So why use set notation? Well, set notation helps us organize and understand groups of objects clearly. It's used in many areas of maths, science, and everyday life, like when we talk about groups of numbers or students in a class or items in a store. So this is something we do every day, and all we're doing today is looking at how we write it down in a mathematical way. So before we look at how we label the Venn diagrams, let's have a look at normal probability first of all. So the probability of an outcome occurring, so outcome A, is shown as the P for probability in brackets A. So that is the probability of outcome A occurring. The probability of outcome A not happening is written as P in brackets A dash. That's known as the complement to A. So for example, if we have a fair die, we know the probability of getting a 6 on a fair die is 1 out of 6. There are 6 sides and there's only one side with the 6 on it. So the chance of not getting a 6, notice the dash, is equal to 1. Well, that 1 is represented by 6 over 6, minus the chance of getting a 6, which is 1 over 6, gives us the answer of 5 over 6. So this Greek letter, and we pronounce that xi, represents the universal set, and that contains all of the elements used. So it's everything included in here. Now notice that the elements of A are in the shaded area of the circle. So the elements of A only sit in that circle, and if they're not elements of A, they would sit outside of that circle. So here we are again. We have Kasai, and that it says all of the elements inside there, and the elements of set A are in that circle. So, and the elements of not set A are shaded, and that is the complement of A. So the shaded area represents all of the elements that are in the complement of A. In other words, they are not in A. So this Venn diagram here, again, shows the complete set, and elements that are in set A sit in here, elements that are set in set B sit in here, and elements that are in both sets will sit in here. Again, we're looking at the elements that are shared. So these elements here are in both sets A and B. So this shaded area represents the elements that are in both A and B, and that's called the intersection. And it's written as A intersection B. So we use this upside down U to represent the intersection. And on this one here, where both A and B are shaded, so we're looking at all of the elements in A and the elements in B, and that's called a combined set. So they're shaded, and they contain all of A and all of B, and that is called the union, and that is written as A U B. Not really a U, but it looks like a U. So all of A and B together are considered to be the union, and it's written as A, U, B. So we'll just do a quick look at a Venn diagram here, and in the next video we'll do those in more detail. So this Venn diagram shows the number of students who study geography, G, and history, H. We have got a total number of students here studying geography and a total number of students here studying history. We've also got this number 2 here. All of these elements include people who study geography, people who study history, and people who don't study either. And that's where that 2 comes in. So there are 2 people that don't study history or geography. Let's look through this. So in this one, we can see that 18 students, that's the 15 plus the 3. So 18 students study geography. We can see 19 students study history. That's the 16 plus the 3. We can see 3 students study both history and geography. That's the intersection, the shared area. We can see 15 students only study geography, and we can see 16 students only study history. And as we started with, we can see 2 students don't study history or geography. And finally, if we add these together, we can see there are 36 students in total. As always, if you've got something from this, please like and subscribe, and we'll see you in the next video.